Hello there, my name is Noah Geiger. This is Lab 4, where we're going to be talking about oscillation and the energy principle. A little bit of background and purpose for this lab. Purpose to predict the motion of the system using the fundamental principles we have learned. Some of the fundamental principles that we'll be talking about today are Newton's second law and the energy principle. Our system is going to be the mass, the spring, in the earth, and our surroundings are going to be nothing because all of it's in the system, or everything that affects it is in the system. Important equations, of course, we're going to have the kinetic, the gravitational, the spring energies. We're going to have total energy, and we're going to, of course, have force due to gravity. That will be important. These right here, these are our initial conditions set by a certain lab, and these are what we're going to be following for the lab. So first thing we did was, of course, we went and we did the tracker. So we tracked the video here. You can see kind of tracked its motion, got our data all here. We then went to GoScript and we went to coding. So we set our, just for the experimental type, um, we set our initial systems for what it was before. So we had our mass, uh, the spring constant, the gravitational constant, the relaxed length, all etc. And then we inputted, or we at least made the code that will be responsible for our graphing. So, and this is all using, of course, the energy principle and Newton's second law, all that good stuff here. We're going to run this code. We go here. We get our data from our tracker. Open it. You kind of see it's going, it's going. Um, keep going, keep going, keep going. Cool. All right, and we have a little bit of an issue. It doesn't exactly work. Why? I'm not exactly sure. I believe it did pretty well when it was X versus time. In terms of it was almost synced. However, Y versus time just didn't work at all. I tried doing the tracker a few times, and the best thing I can just think of is just the tracker, a little bit of inconsistency here, but we have enough here to kind of prove our major points. Um, which is that you can use the experimental or the model, or sorry, you can use the experiment to predict what the spring is going to do, like what motion it's going to take. Now, moving on to what does it all mean? Is the energy principle satisfied? In our model, not really, because our model is not very good. However, we can kind of see some of the principles of it showing. X versus time should be kind of inversely related to Y versus time. And you kind of see it kind of is like the peak of Y versus time is kind of the trough of X versus time, which is sort of what the energy principle is about. You know, you're not going to have um, the total energy should equal total change of energy should equal zero because you know you can't create or take away energy there. Um, and then second question is by estimating the period of oscillation from X position data and then estimating the period from Y data, compare the two estimates. Well, we can kind of see right here the reason why the estimates being different. You can see they're going to be different, obviously, from this data, but they're going to be slightly different. The reason why that's kind of important is because period affects um calculating the K constant of the spring. So if you were trying to calculate constant of the spring, say we didn't have this, right, and we have, you know, two different values, right, it's going to, of course, affect the spring constant, which will affect other things. So thank you so much for watching. Keep it in short and sweet, and have a great spring break.